Okay, this is the fourth NetworkX video. Let me close out that third one. So navigate to the starter for the fourth one. So now we're going to use a little bit richer data set that has more than just node numbers and adjacencies. So maybe first you should, before doing this exercise, you need to have GeoPandas installed on your computer. So this is needed for reading in this particular input file, and it's also GeoPandas comes packaged with some kind of GIS software. So that's useful for drawing maps. So, okay, so if you've installed GeoPandas, this first cell should run properly. It might take a few seconds to import it. Okay, so mine imported properly. I have a 1 next to the cell. If you get any sort of an error here when you run this cell, there's either something wrong with your GeoPandas installation, or somehow GeoPandas isn't linked up with Jupyter Notebook. So if you haven't installed GeoPandas, I encourage you to watch the video that's on Canvas. I can point you here. There's this link right here, how to install GeoPandas. I think that'll take you to maybe to YouTube or something. I have a video of how to install GeoPandas. If you follow this installation guide and you still have troubles with GeoPandas, I encourage you to stop by my office hours on Monday, 3 to 5 p.m. I can try to help you. Okay. So let's see. So we're going to read in this particular file. And actually, I think the file that's in that repository, the one that is in here, this is the file I would normally read in, but that's actually now outdated. This is the file for the 2010 census. So I think we should start working with the 2020 census numbers. So for that, you should go back to Canvas and go under the project module, and there's something called Districting Data 2020 County. So download that. And then you should have something like this, the zip file. So I'll go ahead and extract the zip file. So this has data for all of the states, US states, not just Oklahoma. So for your projects, you may want to use the data that's in here. Okay. So I'll go in here. You see I've got all of the states labeled by, I guess, the two-letter state. And they're all county level graphs, or county level shape files for the GIS software. So if you'd like to work with census tracts or census blocks, you can let me know and I can send you those data files, but they're much larger, so I don't put them on Canvas. Okay, so we want Oklahoma. So I'm going to take all of the files that relate to Oklahoma, all of them that start off OK underscore. So to make this easy, I'm just going to copy those ones that I need. And then I'll put it in here under the districting data folder. Or, yeah, I'll do that. Or, no, okay. How about this? How about I'll refer to the files where they're at. Okay, this will work. So I'll just take this as my file path. If you store it somewhere else, just make sure you copy the appropriate file path. Okay, so here when I do the file path, do that. I'll make it a string, and then I'll have to replace all of these backslashes with double backslash. And then I'll put 2 at the end. Okay. So now I can refer to that particular file, the 2020 data in this folder. And the nice thing, once you install Jerry Chain, is you can read in this graph and all of the associated data in one line. So do this. Let's see if this runs. Cool. Okay, so let's just double check. The Oklahoma County graph has these nodes. And they're numbered 0 through 76. And at least in this case, this list is already sorted. Okay, so when we start doing redistricting, we would like to know more information than just county 0, county 1, county 2. We need to know, at the very least, like what's the name of the county, what's the population of the county, and so on. So fortunately for us, whenever we read in this graph, it actually read in all of those other attributes at once. So we don't have to read those separately. We don't have to input that ourselves. So just to show you that you can access all of that information, we'll say for every one of these nodes, we'll print some information. So I guess the county name is going to be stored here. So for each one of those nodes, named node, we're looking at the attribute name 20. So this is the county name in 2020. If you look on GitHub, the repository that I have there, this will say name 10 because it was reading the data files from the 2010 census. I can also get the county population. And let's see, this one is going to be a little trickier. Give me just 1 second. Okay, here we go. So there are a lot of different populations that are stored for each node, and so we want the total population. Let's see. So the total population is stored here. That's the attribute. So maybe what I could do to make it easier, if I want to just refer to the total population, I could create a new attribute, store it there as well. So if you're interested in getting other populations, so if you want, I guess, any number of whatever demographic group you're looking at, if you want to know the number of people from that group in this county, that is available. I think there are 64 different race or ethnic categories in the 2020 census, and so they have different numbers here. But this one is just the total. Okay, if you're interested in getting that other information, let me know, and I can tell you what those codes are for what you would need to put here to get that information. Okay. So I've got the county's name and the county's population. Okay. So let's print it for every county. We'll say county name, county, had a population of in the 2020 census. Okay, so we can find Payne County. So if you didn't know, OSU and Stillwater were located in Payne County. So we had a population of 81,646. Maybe I could also say, maybe I could also print the node number for each of these. Say node represents county, which had a population of that. Okay, so that's why they're presented in this way. Node 0, node 1. So node, where is Payne County? Node 42 represents Payne County. Okay. So we may be interested to know what are the neighbors of Payne County. So remember that Payne County is 42. Okay. So neighbors of Payne County are all nodes J belong to G dot neighbors of 42. I think previously node 0 used to be Payne County in the 2010 data, but for whatever reason, Payne County is now 42. Okay. So those are the neighbors, and then we can maybe also get what are the names of those counties. So this would be these. So we look at every neighbor J, and then we kind of record what is the name of that node number. So J here is representing the node number. Okay. So at these, the neighboring nodes are the neighbors of node 42. Are here. I guess another way I could have done this is like what I did in the other video. If I just converted that to a list, that should also work. But I'll put it more like how I had it here. Okay. And then also print the names. So their names are neighbor names. Maybe I could just write it out. Counties that neighbor are okay. So Payne County has 1, 2, 3, 4, 5 neighboring counties, and they are Logan, Pawnee, Lincoln, Creek, and Noble. So maybe we check that. So I'll just go to Google image search, Oklahoma County map. This one looks good. Okay, so here's Payne County where we are. It neighbors 1, 2, 3, 4, 5 counties. Pawnee Creek, Lincoln, Logan, Noble. Pawnee Creek, Lincoln, Logan, Noble. Okay, so everything checks out. Okay, so far we've just worked with the graphs themselves, but we can also now draw maps. So the particular Python package for that that we're going to use is GeoPandas, and this should come installed if you got JerryChain installed properly. This should come with it, but I'll need to run that cell to make sure it loads. Okay, and so for the geographic data, I need to get what's called a shape file, and that should be stored. It's in here. So whenever we looked at all of those Oklahoma files, let's see, where's Oklahoma? We had those files, looks like 6 files. This JSON file, JavaScript object notation, the JSON file stores the graph and all of those, like the populations and the names of the counties and whatnot. The other files, those 5 other files are related to the geographic data, to the kind of the map data. And when we read in the files, we'll actually the code will only refer to one file, the shape file, but actually the others are also needed. So if you don't have the other, if you don't have this, I forget what CPG stands for. If you don't have that, if you don't have DBF, database frame, I'm not sure. PRJ, I think, stands for projection, map projection. And I don't remember what SHX stands for, but anyway, our code will only refer to this file, but I think in the process of reading that, it somehow refers or uses the others. So you need all of them. Okay. So when I read in this file, I'll need to make sure that I have the file path and file name correct. I think the file name is correct, but the file path I should update. It's going to be the same as what I had up here. Okay, so now I'll read in the shape file. Conveniently, this is in one line. Okay, so I'm using GeoPandas, which I had imported as GPG. And then I'm reading the file here, and I'm storing it as DF. DF stands for data frame. But okay, seems to have read it in properly. Okay. So now let's suppose, what if you took Payne County and you took, which is now node 42, and you took all of its neighboring counties, those 5 neighboring counties. So hypothetically, if that was a district, what would it look like? So our district would then consist of node 42 plus all of those neighbors. We had already defined up here, so I could just call it neighbors if I want to. And then I need to refer to each of these counties with their geo ID. So I'll define a list of all of the geo IDs of all of these nodes in this district. So Payne County and its neighbors. So I'll do g.nodes I, and then I want to get geo ID 20. So again, the 20 is for the 2020 census. Some of the other files on GitHub may refer to geo ID 10 for the 2010 census. Okay, so we want the geo ID of node I, and we want that for all of the nodes I in the district. So maybe if I wanted to, I could print nodes more specifically. And then I could also print their geo IDs. Okay. So those are those 5 nodes, or I guess 6 nodes if you include Payne County. And then here are their geo IDs. And I can describe this more later if you're interested, but basically each one of these geo IDs for the counties are going to consist of 5 digits. And this will be true for all of the states that you're looking at. The first 2 digits, which is 40 for each one of these, that refers to the state. So if you're working with a different state, these first 2 digits will be something different than 40. If you're interested in what that would be, you should look up FIPS codes. No, okay, that's too detailed. Let's see if I can find. Oh, that's the one I clicked on. Okay, here we go. So each state, we have our 2-letter abbreviation, and then there's also a numeric quantity. So for Oklahoma, it's 40. Okay, so that's what those first 2 digits are referring to. The next 3 digits are referring to the county itself. So I guess the first county here, 42, that's for Payne County. So I think this 119, that's referring to Payne County in Oklahoma. So I guess when you specify all 5 digits, it tells you the state and then the county within that state. If you wanted to refer to even more granular geographic units, if you wanted to refer to something smaller like a census tract or even like a census block, you would have similar geo IDs, except you just have more digits here. So if you were referring to a census tract that's within Payne County, it would start off with these 5 digits, and then it would have some more digits to specify which tract within the county. So if you're interested in learning about that, you can search for, I think GeoID should do it. Okay, yeah, I think this is a good page. Understanding geographic identifiers from the census. And there's an example here. Yeah, okay. So the first 2 digits are the state. The first 2 plus 3 digits, state or county. If you're working with census tracts, you'll have two digits for the state, 3 digits for the county, and then another 6 digits for the tract. And then if you work with blocks, which are nested inside of tracts, you get an additional 4 digits. Okay. So we'll use these GeoIDs, and that will kind of allow us to relate these entities between our graph and between the map. Okay. So we're going to color the counties of Oklahoma one color or another, depending on if they're in this district or if the associated GeoID is in here or not. So for nodes in the district, I'm going to add kind of a column to our data frame called selected. It'll tell us if it's selected in this district, and we're going to set those values to 1 for anything that's in our district, and we'll set the others to 0. And GeoPandas will then use these 0, 1 values to pick colors. So in our data frame, we're going to be adding kind of a new field called selected. So a data frame is almost like a table. You can think of it that way, like a table or a matrix, something like an Excel spreadsheet. Okay, so we're going to add essentially a new column to our spreadsheet or our data frame, and it's going to be a 1 if the GeoID of our node I is in our set of GeoIDs. So all of the things in here we want to associate a 1 to. Otherwise, we're going to associate a 0. And we want to do this for all nodes I. Okay. So this is understandably, this is kind of complicated, but this is a one-line way to add a new, essentially a new column to our data frame. Okay, so now we want to draw it. So I'll create a figure for that. And so I'm going to take that data frame and I'm going to plot specifically the column associated with this kind of the selected field that I just added. And then I'll do dot get figure. And if I did this properly, maybe I can add this to it. In this last cell, it should draw my map. And so there should be Payne County in the middle, and then all of its 5 counties surrounding it. Okay, so this will work if you're just trying to identify associating a binary value for each county. Either it's picked or it's not. The picked ones in this case are showing as yellow here. Later, I'll show you how to do the same thing, but for districts. So Oklahoma has 5 congressional districts, and so you would want 5 different colors. So I'll talk about that later. Okay, I think that does it for NetworkX and for starting to learning how to work with GeoPandas. If you had any troubles with this, let me know, maybe stop by office hours. I don't know if, I think Parisa probably doesn't have experience with this, so I'm probably your best bet. Office hours Mondays 3 to 5.